So first what I did was I found the domain and range of the inverse cosine parent function and the inverse secant parent function. And then I made my two equations and I kind of like sketched a graph of them. And I made these 2 points because this helps represent the domain and range. So first, in order to find the range, I just took my original range values for each of the functions and I multiplied them by 3 because that's representing our vertical stretch. And the vertical stretch affects all the y values and range deals with y values. And you also have to include the vertical shift of negative pi over 7. So I did that to each of the values in the ranges, and I got this as the range for my f of x function and this as the range as my g of x function. And the ranges are pretty much the same. As you can see, they start at negative pi over 7 and end at 20 pi over 7. The only difference is that the secant inverse graph has a horizontal asymptote that goes right along here. It goes right through the middle of the inverse cosine graph, and it's at 19 pi over 14. So that's the only difference in the ranges. So next what I did was I found the domains by them by taking my range value of 20 pi over 7 and plugging it in for the y value and solving for x. And if you use secant or cosine inverse, you're going to end up getting the same answer of either 5.8 or 6.2. So by looking at my graph, I looked at this and I saw that the domain for f of x is obviously going to be between 5.8 and the 6.2, while the inverse secant domains is going to be from negative infinity to that 5.8, and then there's going to be a union where that cosine function is, the inverse cosine function is, and then it's going to start again at the 6.2 and go to infinity. So when you're comparing the domains of the two functions, the inverse cosine domain is in between the inverse secant. It's like right where this union would be. And yeah.